My name is Adam Wenchel. I'm the CEO of Arthur.ai. We've been around for a little over a year, but we just came out of our quasi-stealth mode about a month ago, right before the holidays. We are a model monitoring company. Prior to this, I was with Capital One. I was acquired into Capital One in my previous startup. I spent 3 years there founding and scaling up their AI team to a little over 200 people and doing AI projects across all their different lines of business. And actually been doing AI for a while. Started my career in DARPA way back in the day. So a little bit about me. What I wanted to share today is just, I was told I actually had to make it useful for people. So for starters, who here works for an organization that has an AI strategy, beginning to put one together, beginning to invest in AI? How many people? Just quick show of hands. All right, pretty good. Not bad, not bad. Here's some of the lessons that I've learned the hard way. Have quite a few battle scars from taking AI, works great in the lab. What happens when you move it into production? So a couple of things to just to kind of set the ground for this. We all know the world is run by AI. Everything is run by AI, right? Well, not quite, but we're getting there, right? So clearly there's a trend, right, where businesses are moving more and more of their operations, of their core leverage points onto AI, whether it's distribution centers or credit models or healthcare predictive analytics. I mean, the things that AI is doing, driving cars, it grows more and more every year. And then the good news about that is it always works flawlessly. And it always works flawlessly in the lab. You guys might have seen a couple headlines in like the rare cases where it doesn't work flawlessly. AI is hard. It's hard, and it's not only hard to develop in the lab, but once you develop it and put it in the real world, there's a whole new set of categories of ways it can go wrong, and we're going to talk about a few of those. There's lots of problems, but there's kind of three general themes that we see most commonly that I wanted to walk over. Your model making bad decisions, right? Your AI system's making bad decisions. If you're a for-profit commercial enterprise, that frequently means you're losing money. It can also mean all sorts of bad outcomes for people, the people you're serving, whether it's patients or financial clients. Inappropriate or illegal decisions. So, there's plenty of headlines around this. In addition to a bunch of new AI regulation that's rolling out, there's a lot of historical regulation around anti-discrimination and bias and things like that certainly applies just as much to AI models as it does to humans and more simple analytical models. And then the other big thing falls into the category of trust, which is how do I convince other internal business stakeholders and members of the public, or the people we're serving, our customers, that just because we've developed this brand new hotshot AI system, like before we get into production, how do people believe that it's going to work? And we encounter this all the time, where in organizations they have these big plans for AI, but they're unsure about actually deploying them and turning them on, and things get held up for months and months and months because of that. So let's double click on these bad decisions. And actually, first, the disclaimer, I put some headlines in here just to kind of illustrate the point. I don't mean to pick on any of the companies mentioned in these news articles, because I can tell you that every company that's doing anything substantive with AI probably suffers from any of these problems. It's just a few of them have actually made the headlines for it. And so, don't, it's not intended to AI shame them or anything like that. They just happen to be lucky. When you deploy an AI system and you test it in the lab, back test it against a bunch of your historical data, it's typically people get pretty excited about the results they see. But the second you put it in the real world, models, number one, there's a gap right from day one, and they get worse over time. And why is that? So there's a few reasons. One, the world doesn't stand still. It changes, right? And so macroeconomic conditions change, like health outbreaks occur, like all sorts of things change, climate changes, and that causes whatever the data that you're reasoning about to look different than what you trained on. And that can be very gradual over time type of effect, and something like a macroeconomic shift can be more sudden, which is something like your marketing department all of a sudden starts this brand new marketing campaign to a completely different segment of the population than you've historically serviced, and now all of a sudden your model's having to reason about people from which it's really not familiar, and which it really hasn't seen many of examples in the past. And then it can happen even more drastically, and this happens all the time, where something like your system is fed by data from a bunch of other systems, and some enterprising developer makes an inconsequential change to that upstream system, and all of a sudden the data flowing into your system is encoded slightly differently or coming in a slightly different format, And your model's like, oh no, I'm good, I can keep making decisions, it's fine. But in fact, it's making terrible, terrible decisions. And so, that can cause hundreds of millions of dollars worth of damage over time. And kind of key to all these problems, what makes them really damning is that most organizations, almost every organization, does not have good organizational practices around this. So, if you imagine, like, those of you familiar with Security Operations Center or Technology Operations Centers, the way you have like 24/7 staffed centers. So if your Technology Operations Center could be running Datadog or a number of tools, your Security Operations Center might be running Splunk, and you have organizations kind of built around these sort of consoles to do that. Unfortunately, in most organizations, the same doesn't exist around analytical models and AI. So a lot of times what happens is the data scientists develop a model, they put it into production, they kind of babysit it for the first couple of weeks. They kind of get, they feel good about it, they get complacent, they move on to the next project, they get reorged, they lose the company. Some really mature organizations with a mature risk practices like banks, they'll actually have a quarterly process where they'll go and kind of like take a look and say, oh, that looks about right once a quarter. And the reality is those aren't that effective in an AI world. And so you really need some sort of automated practice and an organization around that. Inappropriate and illegal decisions. So there's been a lot about this in the headlines. And there's a few things. There's both kind of like the regulatory risk, but there's also a lot of reputational damage, and we've seen that firsthand recently. Whether it's fair or not, if you don't have the right, a lot of times, sometimes these headlines aren't even accurate. They're not even fair. But if you don't have these kind of tools in place that you can demonstrate that you're being fair, you're really sort of not in a good position to dispute that. And what's happened a lot in the past is people have kind of like taken the head in the sand approach, where they've sort of said like, we're not even collecting protected classes, so we can't possibly be biased as far as we know. And that's no longer good enough. You now actually need to actively kind of monitor for bias and make sure that your data scientists are incorporating notions of fairness in the algorithms. You need the tools to do that with. And then lastly, how do I trust this? And there's a great, this Forbes article, one of the things that the quotes I really like is, it's talking about the rollout of a new healthcare prescription recommendation system. And, talking to the doctors, when the model kind of said something that they already knew, like, hey, this person is, this is the diagnosis. They said, of course, everyone knows that. It's obvious, I do that. And when the model says something that different than what they thought, they're like, this piece of junk system, it can't be trusted, right? And so that's the refrain you see. And so being able to actually say not just what the decision was made, but why you made that decision allows that the professional in this kind of human in the loop case to say, all right, now I see what the model was saying, that's great. Or say, actually, I need to put that into the feedback loop, and we need to make the model better so it misses these cases, and it gives it a lot more to go on. That's one way. There's a lot of other ways, trust is built. I think having, again, these kind of monitoring processes so that you know that if something goes wrong, you're going to detect it within seconds, not within months, is really key to gaining to gaining trust. Because if you have like a credit decision model where you're whether it's auto loans or home mortgages or credit cards, there's hundreds of millions of dollars at stake there and billions of dollars at stake. And so even if your model encounters some sort of issue that drops it a couple tenths of a percent in performance, that can literally be hundreds of millions of dollars over time. And so the ROI on having that kind of monitoring in place is huge. And what we see a lot is for organizations adopting it, especially large traditional enterprises, they tend to be very consensus-driven cultures by nature. And so even if a data scientist can demonstrate they have a model that gets some huge 5 or 10% lift, which again, it could be hundreds of millions of dollars in upside for the business. If there's this sort of risk of the unknown, right, with putting a new model in there, and if you don't have a way to mitigate that, it's really hard to kind of get internal stakeholders to sign off on the adoption of that. So this issue of trust is really huge. So let's walk through just a couple of case studies. While most of the projects we work on aren't yet public, but there's a couple that have been covered in the media. Wired magazine wrote an article about this in November. But Harvard, Dumbarton Oaks, which is a research division of Harvard University, it's the world's preeminent research institution for pre-Columbian art and Byzantine art and antiquities and archaeology. They actually had this really cool project which was on using computer vision. And so what happens is a lot of the Byzantine archaeological sites they study, they have people donate thousands of images to them from like 50 or 80 years ago, and they're these really valuable historical image sets that captured these sites before they got like destroyed or were developed. A lot of these places are in conflict-ravaged places, and they really there's like a sense of urgency to analyze these because there's still kind of ongoing conflict in all these regions, and they really want to kind of make sure they understand them while they have the best chance of if they need to gather more information, they can do it. And so what they did in here is they really were able to leverage the explainability for a couple of the to address a couple of the problems we had that I mentioned. So first, improving the performance of the models, right? This is an example. These are some of the images they have, and you can see the classes they're categorized with. Some of the architecture terms here get pretty esoteric. And for each of these, you can actually use explainability techniques to say not just what do you think this is, but why. And so here, this is an example of, well, the model thinks it's a lintel. These are the area in the image where that most make the model think it's a lintel. And then in red, that's the part that makes it think it's not a lintel, because that curved form is in fact something completely different. And so what they were able to do using this is two things. One, they were able to surface in times when the model is wrong. Why was it wrong? And so this is an example of I'm told this was an example of a nave, which is, I am not a postdoc humanities researcher, but what they found was in their training, the model, a lot of what images it identified as naves, it was highlighting areas of vegetation. And it turned out it was because in their image sets, it just so happened that a lot of the nave examples they had like bushes growing in them. And so one of the ways they were able to improve the accuracy of their model was say, hey, let's find some pictures of naves that don't have bushes growing in them, label them as naves, retrain the model on that. And so they were able to get a much better model out of it. And then the other thing is, you can imagine this world of humanities research has not changed a whole lot in the last 200 years of study. And so bringing this sort of innovation, like we can automate this and computers can find patterns that we've never seen before, wasn't met with immediate acceptance, I'll put it that way. But by using things like explainability, they're able to kind of, it's a good way to kind of show people like, look, it's not just like, the model's not just guessing. Like there's some rhyme and reason to the predictions it's making, and here you can see that. And so it's been really helpful to gaining acceptance in the scholarly community. Another quick one, I'm running short on time, so I'm gonna run through this, but it was a project that we collaborated on with the United States Air Force, and they were redoing the way they do supply chain, which is many billions of dollars problems. And keeping the airplanes flying, these airplanes are designated as critical national defense systems. So you can imagine if they have to ground a fleet because they ran out of a part, then it's not a good look. And each engine, this one engine here alone, has about 30,000 parts in it from thousands of different suppliers, and they have to be distributed at bases across the globe where these planes fly out of. And so it's just an immensely challenging problem to optimize that. And it's a zero-sum game, so if they order more of one part, they have to order less of another. And so getting that optimized is critical. And so they used AI to do it. They're getting good results out of that. But monitoring for performance, so that making sure it's continuing to work well in the real world, and being able to explain the decisions, right? Like again, if you run out of a part and you have to ground a fleet and you get hauled in front of your commanding officer or in front of Congress to explain it, you don't want to be saying because the black box told me to do it. You want to be able to provide an explanation. And so something like this is actually a different data set because I'm not allowed to share the Air Force data publicly, but you can tell you like each of the factors and how they contributed to the decision, whether positively or negatively, how significantly they contributed. So I guess that's kind of the short intro. Ultimately, we think this is a positive message. Like the more you can build these guardrails in from kind of day one of your AI projects, it allows you to be more aggressive, right? Just like the safety systems on an F1 car allow you to lap faster. If you build this stuff in from the beginning and learn from these lessons, then you can be more aggressive with your AI strategy. And ultimately, what we envision is like helping companies run their company like a Kaggle competition, right? Where you're actually putting models out, and there's like this sort of meritocratic fight for efficiency, and really you can do that in a way that is trusted. So that's production AI. One more thing I do want to put in a plug for, we are hiring engineers in particular. Some of my colleagues are here. Raise your hands, guys. Definitely come talk to one of us afterwards if you're interested in, if you're an engineer of any sort and interested in a new position with an exciting company. Thank you.
Very cool. Do you want to talk a little more about the specifics to the extent you can? Actually, I don't know if you can, but like, how does that work? And does that work? I mean, AI means lots of different things, like from deep learning and NLP. Like, does it work? Is a model for your purposes, or?
Yes, we primarily see like our focus is on tabular business data, computer vision, NLP. Those are the ones that we see the most regularly. And there's plenty of other examples, but that covers a huge part of the market. And we are kind of agnostic. Like, people can build their models. Like, what we see in large organizations, they have this really heterogeneous mix of modeling environments. They're using Data Robot and H2O and open source and cloud providers like AWS SageMaker and things like that. And that's great. Like, I think it's important to allow this kind of highly sought after data science talent to be free to use whatever tools they want. But you don't want to have to check 87 different places just to understand kind of what the overall health of the AI across your organization is. Yeah.
And so how does that work? You just ingest a lot of data into a centralized platform, and you just monitor everything?
Yeah, it's similar to Datadog or any other monitoring platform for different purposes. But you have an agent that deploys next to your model and captures the data, sends it back to an analytics central platform from the analytics, whether it's running on-prem or in the cloud, and does the analysis there.
Yeah. And what benchmark do you compare the data against?
So there's depends on what you're trying to do, but for things like monitoring how much the data changes, you can monitor both against the data you trained on. You can also monitor it over time, like, hey, was the data at 5 o'clock on Tuesday the same as last week at 5 o'clock Tuesday? So there's different ways you can set that up, and it really is kind of use case specific. Yeah.
Great. Let's open up to questions so that people get a chance to. Don't you need to have access to the underlying data set at some point, like to figure out what's going on, and it's just the performance of the model?
So when you talk about performance of the model, there's kind of like two broad categories. One is systems where you have a ground truth feedback loop. Yep. So an advertising campaign, like, I know pretty quickly whether people clicked on it. Right. There's like some metrics you can gather. There's other ones like underwriting credit cards, where you might not know for 3 or 4 years whether you should have given that person a credit card, right? And so in those cases, you have to look at a lot of proxy metrics, which is where we get into things like data drift and measuring, does the data I'm seeing in the real world look like what I trained off of, and that kind of metrics? And if I'm have a classification model, are there any significant shifts in like what I'm identifying? Like, yesterday, my car thought 27% of signs were stop signs. Now all of a sudden it's seeing 50% of the signs it sees are stop signs. Like, maybe I should take a look at that. Mm-hmm. Yeah.
Hey there, great talk. Thanks. I was curious if, given your DARPA background, if your work is related at all to the explainable AI program at DARPA, and if so, is it similar, different?
So my DARPA experience was long before the XAI project is, but certainly, some of the techniques that were explored in the XAI program were of a similar ilk to what we're doing. We're obviously focused on making them easy to deploy and scale to enterprise scale. But yeah, absolutely, our XAI project has borne a lot of good techniques into the world for sure.
I have a brief question, but there's some context to it, which is, who do you really sell this to in the context of all this? In other words, what role do you go to? Because the context of all this, of course, data scientists are like herds of cats. They like to all use their different tools. No reason why not. So who do you sell this to? Because you need to have some sort of common source of ground truth on like how your models are performing.
It's a good question, and I think, in terms of like how companies are organized around AI, it's still kind of an evolving thing, right? Because AI is relatively new. But typically we find that there's a head of data science or analytics that we sell into. Oftentimes, more and more, we're seeing people have a head of AI infrastructure who's responsible for building out the tooling for the organization. There is definitely a tension, as you said, between giving people, like, it's so hard to find good data scientists. The last thing you want to do is turn them off by forcing them to use some tool that they may or may not want to use. And so I think enterprises are starting to become more comfortable giving people more latitude, and that's great. And in some ways, we feel like our tool enables that, because rather than making everyone standardize on this exact stack, we're saying, use whatever stack you want, just make sure you're monitoring it consistently.
Hi. With respect to explainability, you showed some slides with images where you could see what parts had the most influence, and the tool I'm most familiar with that's open source is Lime, that you could kind of tweak some things in the image or tweak some things in the sentence and see what impact it has. Do you leverage that, or do you do something technically different than what these open source
What we do
tools
is built off a lot. So, the thing about explainability, especially when you're talking about kind of acceptances, it kind of needs to be peer reviewed, right, to be valuable for everyone to kind of agree that what you're doing is valid. And so a lot of what we're doing is based off of like the line paper, SHAP, integrated gradients, some of these techniques. I think the key is, again, those like if you look at the open source components, they're not very scalable. They're not easy to deploy at scale. They're useful, like if you're a data scientist and you have your Jupyter notebook and you're running an experiment locally, like they work great for that. But if you try to scale them up to any sort of enterprise scale application, it's not. This was written by, no offense to the PhDs on our team, but they were written by PhDs as proof of concept to back up their academic paper. Sorry, John.
All right, awesome. That was terrific. Thank you so much.
Thanks, Matt.